Well, here we are with test 8. Hope you've been enjoying those little classroom videos I've been shoehorning in between these things, and some of that stuff is it's interesting to me when I listen to it, or it may be boring to you. But I tell a lot of stories and stuff. Anyway, welcome to the channel this morning. Let's get started on this test. Question 1. Why do newer shop manuals refer to the alternator as a generator? Does it denote DC voltage? Is it the federal J1930 regulation? Does it match gen dash lights? Or to avoid starter confusion? Question 2. Well, we're driving along here in our 04 Explorer. Which of these is most likely to trigger an ignition misfire bite? High-speed cruise, wide open throttle acceleration, low RPM torque converter clutch lock, or idle with AC active? Question 3. What's being measured here? Is this valve lash, lobe lift, lifter wear, or push rod? Question 4. A vehicle has a no DTC stored hard to duplicate intermittent misfire. Most likely cause would be coil pack failure, carbon foul plug, unseated terminal, or rounded cam lobe. Question 5. What does TWC mean on a Ford vehicle emission control information decal? Does it mean twisted wire CAN bus, three-way catalyst, tightly wound camshaft, or tone-wheeled crank? Question 6. When is the ignition timing most advanced? Hot highway cruise, cold weather start, wide open throttle uphill pulling, or fully flowing EGR? Question 7. First step in checking a crank's normally but no start issue would be fuel pressure, spark strength, injector action, or mass airflow sensor. Question 8. Spark plug center electrode resistance should be A, 2,000 to 8,000 ohms, B, 0 to 2,800 ohms, C, less than or equal to 10,000 ohms, or D, not measured. Question 9. High CO readings on an emission test indicate A, lean air fuel mixture, B, plug gap set too wide, C, rich air fuel mixture, or D, excessive EGR flow. Question 10. A lean air fuel mixture will produce high HC, CO, NOx, or CO2. All right, now we moved pretty fast through the first part of this test. Of course, you can pause the video at any other questions if you need to think about it. That's part of the deal. And here are our answers. Question 1. This is the federal J1930 regulation. Now, some years ago, I wrote an article for Motor Age. I was requested to write an article specifically about alternators, and I was given the contact information for Visteon to talk to one of their engineers about, when I was writing this article, to get all the information about that, because part of this was highlighting Visteon products. I also wrote one about ignition coils. I can show those to y'all if you ever want to see them. But anyway, I was telling the guy that I was talking to on the phone from Visteon, I says typically they call this a generator nowadays. The way I understand it, it's part of the standardization, terminology standardization. And he says, no, I don't care what anybody says, this is an alternator, it's not a generator. But basically the rule would be, if you look up the list of these standardized terms, and it's been changed over the years a few times. In other words, it started out in '88, and then it moved up to, that J1930, and then it kept moving up. And a funny little side story, my buddy was working on a Ford Probe that had been at a shop where they had replaced the alternator. It was an independent shop. Somehow, I don't know how they did this, they burned up the engine controller. And so it had to be brought to the, they didn't know why it wouldn't start after they got through. I don't know how they did that, but they brought it, and then he had to figure out what was wrong with it. He put an engine controller on it and got it started again, and the bill was $2,000. And the independent shop took us to court, or took, not me, but the dealership to court, wanting to know, why it was that they charged so much and blah, blah, blah. Of course, the engine controller was really expensive on a Ford Probe, which was basically a Mazda knockoff. And you know how high those things are. Anyway, while the lawyer for the independent shop was questioning my buddy Mark, he says, now you called this a processor. Isn't this supposed to be called an engine controller? And Mark says, well, according to the J1930 regulation, it's the powertrain control module, which would be PCM. But what's most important is that you know how to fix a vehicle without burning one up. And the lawyer was stumped because he'd never heard of the J1930 regulation. But all right, this is going to be low RPM torque converter lock. When you're pulling a light grade and you're crowding the throttle just a little and you're keeping it in high gear with a torque converter lock, that's when you're most likely to feel a misfire. Now, I worked on an old 66 or 65 Mustang one time this guy brought in that had been totally restored, had a 289 in it, and he wanted a tune-up done by the best guy in the shop and blah, 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 And so I put that was back in those days. I had that big Sun Interrogator sitting in front of my, if you know what that is, sitting in front of my service bay. And so the car ran really smooth, really good, but I went ahead and put new plugs in it, and I put points and, condenser, and set the points like they were supposed to be, set the dwell, and all. I even had a dwell meter in those days. And I don't know what happened to that thing, but anyway, the guy took it and drove it and said, I'm still having the same problem. And so the shop foreman got on it and rode it with him, and this guy was tacking this thing out to about 6,000 RPM, and it was cutting out with him burying the bone, and just, I mean, my goodness, the shop foreman said it sounded like he's trying to blow the engine up. So he brings it back in there, and the older spark plug wires, went through a boot down into the tower socket and the distributor cap, and the guy had replaced his own spark plug wires, and one of the plug wires was stuck down in there where you couldn't see the terminal, but it wasn't pushed all the way down so that it was snapped into its socket. And that particular spark plug was, it had a short, in other words, it was taking 20,000 volts to fire that plug, which means it had a high firing line but a short spark line. And that was causing it to run out of energy whenever you were attacking it out that high. And so the shop foreman told him, if I saw one of my guys driving anybody's car the way you're driving this one, I'd have something to say to him about it. And the guy says, well, that's the way I drive this car. And I thought it was crazy that he drove a perfectly restored 65 Mustang like that, But anyway, just for the sake of argument, I hooked before I did anything else to it, I hooked that interrogator up. It didn't have a scope, but it would give you numbers on the screen about all your firing. And I saw that one of the plugs was firing at 20,000 volts, and the rest of them were firing a whole lot lower. So I went ahead and I found it that way. But that was one of the crazy ones, wide open throttle cruise. So what is being measured here? This is basically going to be lobe lift. Now, I may have mentioned this before, but you see this is on a 4.8, and the guy that was driving a 4.8, I mentioned this before, see the lobe lift spec on that? Okay, this one here was supposed to be 274 thousandths of an inch of lobe lift on the exhaust valve, a little higher on the intake valve. And so what we did is we put a dial indicator, because one of my guys heard something under the valve cover he didn't like. If you drove the vehicle, you couldn't tell there was much of anything wrong with it, because you feel like a 4.8 is kind of gutless anyway. This was like a 2006 Chevy Silverado. And so he says, and Jonathan said, I don't like what I hear under that valve cover. And this kid was 19. He was sharp as a tack. I couldn't hear what he was talking about. May have been old ears, I don't know. But anyway, we pulled it down, and we went ahead and did this valve, this dial indicator hookup, and we set it right on top of the push rod and barred the engine through and measured the amount of valve lift, and it only had about 219,000. This guy had a camshaft that was beginning to round off. Now, a lot of the times, we won't pick up on a camshaft that's rounded off until it starts, popping back through the intake like a machine gun or something. But in this particular case, or making a lot more noise than this one was making, But just driving this vehicle, even doing a volumetric efficiency test, I really didn't see much of anything I could detect. And it was because of Jonathan's sharp ears that he heard the lifter was having trouble maintaining the proper lash, the hydraulic lifter. And so whenever it was doing that, but anyway, that's sort of how I created this illustration, and it was a lot of trouble, so I hope you appreciate it, and round it off. But back in the olden days, a lot of times, when they still had carburetors and stuff, and even after that, if the camshaft was rounded off really bad, when you'd fire it up, it sounded like somebody was shooting a machine gun out the carburetor, which is really funny. All right, so the vehicle's got no DTC. I have actually seen this on a vehicle. Now the connector didn't look exactly like that, but one pushed back connector, like this one here is powering up all the injectors, and these three wires are firing. If one of them pushed back so that it's barely touching, I ran into this on a brand spanking new convertible Mustang one time. It was a white one, little 4-cylinder in it. It's a funny story. And so I'm driving all over town trying to get this thing to misfire. I can't get it to misfire for lower money. And so I'm driving it, and I said, well, I'm over here close to the credit union. All I got was pull in here and get me some money for lunch. So I pulled into the drive-through and, got my money. And the lady that owned the vehicle was driving a loaner car. And so she saw me on her white convertible Mustang at the drive-through, and that's my car. What are you doing running errands on it? And I said, well, I'm driving it all over town anyway. I can't get it to skip. And she said, well, follow me over here to my house, and I'll park this loaner car, and I'll show you the skip. I said, I'd be glad to have you do that, because I want to know what's going on too. So she got in the driver's seat, and she drove that car all over the place. And she could not get it to skip for anything, just like I couldn't get it to skip. And she sort of calmed down a little bit from having seen me at the drive-through. And then she says, I'm sorry I acted so ugly. I won't even mention this to my husband. I said, I didn't get out of the car and go into the credit union. I was just sitting there, and it, figured maybe when I pulled off from there it might skip. And she says, I hope you don't mind that I'm not wearing any makeup and anything, because I've been working in the garden, picking peas. And she was not an attractive lady, with all due respect. I was being nice to her, but I says, just buttering her up a little bit. I said, oh, you don't need any makeup, Wow, that just made her feel really good. But one way or another, when I got back to the shop and I kept looking around, I found a pushed back pin in the connector that was feeding the injectors on the fuel rail. And that's all that was wrong with that Mustang. But it was really, really, really hard to duplicate that misfire. And pushed back pins will do crazy stuff in a connector. I worked on back when I was at the Lincoln Mercury place in 1984, I worked on a town car that was misfiring. They'd crank it up in the morning, and after about 5 minutes, now you got to remember this one here was throttle body injection, and it had a crank sensor, and it didn't have a stator in the distributor or anything, just had a rotor. Anyway, the point is, the thing was, it would cut up exactly 5 minutes after a cold start. When you drove it, it would buck and jump, and then it would straighten up for the rest of the day. And so they brought it over there, and I never really felt it do that, but I just started looking around, and I noticed, the crank sensor, the standard colors for crank sensor wiring for Ford, even way back then, was blue and gray. The wires coming from, going to the crank sensor, and the crank sensor connector had a pushback terminal so that it was barely touching. And that was the reason that it was doing that. Now, what about this 5-minute timeout? I don't know. But when I pushed it in there and got that thing seated, they never had that problem again. And I'm telling you, pushback terminals that are just barely touching will do crazy stuff because of temperature changes and all kinds of other things. Engine torque and, blah, blah. Question 5, three-way catalyst. A lot of you guys probably knew that is what TWC means on that decal. It's down there next to HO2 SSFI and all that stuff. SFI, sequential fuel injection, and HO2S, blah blah and all that stuff. So anyway, the three-way cat system handles NOx, CO, and HC. The brick that handles NOx is the one that's closest to the engine. That's the light-off cat, and it's monitored by the downstream sensor. The rear cat that handles CO and HC is the oxidation cat, and it is not monitored by a sensor. So if you have one that's throwing you a 430 code, it's going to be the front cat that's throwing that. And I have actually seen people replace this rear cat thinking that they were going to fix a PO430, which was actually triggered by the front cat. This cat can just do all kinds of stupid stuff and be totally wrong and not working worth a flip. And these O2 sensors won't have a clue. Unless, if it's clogged up, you're going to have issues with that. But anyway, just remember that. This actually right here was that torque app that I had on the Android radio. I had in my Explorer for a while. It was pretty darn cool. And I had it set up so it would show you all this. There's your lazy downstream sensor and your active upstream sensor, EGR activity, and then I had the evap purge and all kinds of stuff in here. Neat. You could set that up on there, and I could pull that thing up, and this would be on there while I was driving down the road. That really amazed people that didn't know anything about that kind of thing when they rode with me. When is the ignition timing most advanced? And that's going to be at hot highway cruise. If the vehicle's not loaded and you're just holding your speed and you've got it at about 16, 18, 2200 RPM or whatever, that's when your ignition timing is going to be the most advanced. When you're in a pull, it retards, and when you're starting it, it actually goes back to base. When I say retards, it goes back to base timing settings, which I always thought was kind of interesting. That some of your Chevys, the base timing setting was 0 degrees, which I thought was kind of wacky. On the Fords, it was 10 degrees before top dead center. But anyway, when you're at a hot highway cruise holding speed, that's when it's going to be the highest. Alright, so the smart first step is to check spark strength. Don't check fuel pressure and then check spark. That's just a bad idea. And that was, I had told you guys one time, and I did not make the mistake of checking fuel pressure and then spark strength, but I checked the fuel pressure. I had already checked the spark. I put it all back in on this Taurus I was working on. Checked the fuel pressure, and there was a little dab of fuel. Sometimes when you're putting the gauge on there, a little bit of fuel will come out of the Schrader valve, and it'll dribble around there and get on the engine. If you're out there on a service lot, you don't have an air blower to blow that out of there. And so I was out there, and so I'm spinning it over my starter button, with the key. And it didn't start, but there was a spark happened somehow that lit off a little puddle of gas that was under the distributor, and it was, how quick it starts, and I blew it out, and it came back, and I blew it out, and it came back, and I blew it out, and it came back. I must have blown myself completely out of wind. I couldn't leave. I couldn't call anybody. There wasn't anybody close enough to help me, and going to get a fire extinguisher would have been just go ahead and let the car burn, So I kept blowing that out, blowing it out, blowing it out, blowing it out. And it's annoying as all get out how it keeps coming back when you blow it out, Anyway, that's that was my piece of advice I always get my student. Check your spark first. Of course, when you're checking spark, you also need to make sure there's not any fuel leaks, so you don't know fuel on top of the engine. This friend of mine was working on he was trying to do he had some fuel that got all down in the cylinders and hydraulic locked this 4-liter Jeep Cherokee, and it was one of those like an 89 or a 90 model. It had a Bendix fuel injection system on it. It had a cam sensor and a distributor, but the crank sensor over here was where the ignition got its trigger to fire the coil. And so he wasn't all that familiar with these Jeeps. He had worked on other makes, but he never worked on Jeeps. So he was going to say, I'm going to pull the plugs out, and I'm going to just spin it over and let it blow all that gas out of there, because those holes are kind of pointing up anyway. And so he unplugs the distributor, which is the cam sensor, which it does on that one is not going to keep the ignition system from working at all. He spins it over, and of course it's sparking while all that gas is coming out. He said that thing blowing that gas out of them holes and lighting it off with them sparks looked like an anti-aircraft gun shooting up into the sky. Scared the daylights out of him. By some miracle he managed not to set that Jeep on fire, but it was funny to me. Hear him talk about that. The center electrode existence should be 2,000 to 8,000 typically. And I like to measure those. The one I was measuring in this photo right here was only 200 ohms. Of course, on that one there, whenever I had a misfire, I would change the coil pack on that misfiring cylinder, and I would measure the resistance of the plug, which is, always something I like to do. I was doing that before I had ever heard about anybody else doing it. And I actually wrote about that in a Motor Age article. And this is a picture. I actually saw this. I was at the Ford Training Center in Tallahassee, Florida, and there was a guy that was doing a course on one of the computers over there, and this image popped up on the computer with measuring the center electrode resistance, and this is from a Ford training program. And so it was, of course, 8,000 was what we're looking at on that meter there. But it can have a little more than that. But usually the ones that I've measured would have usually 4,000 to 6,000 ohms. And sometimes maybe 3,500, but they need to be even across the board, pretty close. Like within a few hundred ohms of each other. If one of them's way off, then that one's suspect. And so this guy that was a champion spark plug engineer wrote me a scathing letter telling me that it was stupid. You don't measure spark plug center electrode resistance. You're supposed to check it with a scope, blah, 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 blah. And he was just selling me down the road. And so I basically wrote him back and said, look, this is something that Ford puts in their training. You measure the center electrode resistance. And for the fun of it, the next time I got a set of Champion spark plugs, which when I'm working on a Chrysler or something that came with Champions in it, I would put Champions back in it. I laid out a whole brand new set of Champion spark plugs on the bench, and I measured each one of them, and they were all over the map from like 2,000 to 17,000 ohms and everywhere in between. So no wonder the guy didn't want us measuring those things. I had also heard these guys at a Chrysler dealership way back in, 1980, down in Port Arthur, Texas. One of them said that he had replaced the spark plugs in a car, because it came in there with a spark plug base. And after he replaced the plugs, it wouldn't start. And he knew he didn't do anything wrong, and so he put the original plugs back in it, it fired up. Put the new plugs in it, it wouldn't start, and they were Champions. So, and that was a Chrysler dealership, So I'm not hating on Champion plugs. I've used them before, and I never really thought a lot about it. But I'm telling you, measuring the center electrode is a valid test. Now your lawnmower, your racing plugs won't have a resistor in them, but the resistor's in there to reduce RFI, and so you're supposed to have suppressor or resistor plugs. Here's another little funny story. Ford Explorers in 2007, when the 4-liter single overhead cam engine first came out, they all had resistor plugs in them, and that's the one over here. It's just got this resistor. If you ever break one down, you'll see that little pellet there. It's not just a straight shot all the way through like it is on these lawnmower plugs and racing plugs, where they're not worried about RFI. The suppressor plug has got this same resistor, but it's got wire wrapped around it. So these resistor plugs in those Explorers, it was funny because I kept seeing 2007 Ford Explorers that were nearly new that would be misfiring on cylinder number 4, and replacing the plug always took care of it, and it kept doing it again and again and again on cylinder number 4. I mean, I saw a bunch of them, and I was talking to my buddy Donnie, and Donnie doesn't think like I do. Donnie basically wants to gather a lot of information. He wants to sort it out. He has to gather a lot of data before he'll form a conclusion. Well, a lot of the times I'll do stuff on a hunch, and he never understood that. But, proof's in the pudding. If the car is fixed, it's fixed, And so I would look over there. I was talking to him. I said, I've seen a bunch of these on cylinder number 4. He said, there's no way it's always cylinder number 4. I said, yeah, every single time. For me, it's been cylinder number 4. And so there was a transmission mechanic named Mickey that was across the shop while we were talking. And I said, and Mickey says, hey, they brought this in for a transmission problem, and it's got a misfire. And I looked, and it was one of those Explorers. I said, put a number 4 spark plug in it. He said, okay. And so he went and got a number 4 spark plug put in it while Donnie and I were still arguing about that. And when he got through, he said, he hollered back over. He said, that fixed it. And so Donnie was really ticked. And so he pulled up an Explorer in the next day, and he goes, I got one of these misfiring Explorers. Now I'm gonna find out if you're telling me the truth. It's amazing to me. I hadn't seen so many of them. He hadn't seen any. And so Donnie, he's in the parts room, standing leaning on the parts counter. And I came in. I said, which spark plug was it, Donnie? 4. He didn't want to tell me 4. But then later on he goes, well, I did have one the other day that was cylinder number 5. And I said, yeah, but that was a one-off, you know. Anyway, Ford came out with a program where we were supposed to place all the resistor spark plugs in those with suppressor spark plugs because they were having too many warranty claims on, you know, having to replace plugs. I don't know the particulars behind that, although we had to put, you know, suppressor plugs in all those. All right, high CO reading is a rich air-fuel mixture. See, every molecule of fuel, which is hydrocarbon, wants to get married to 2 molecules of oxygen to make CO2, which feeds the grass, doesn't cause global warming. I don't care what anybody says, it's stupid. And then it basically makes, you know, HC and CO. If the mix is right, you're going to get CO2. And CO2 is what you want. If the mixture is too rich and there's not enough oxygen to marry to each hydrocarbon molecule, you're going to have HC, which is no oxygen, and CO, which is a very poisonous gas, and it's 1 molecule of hydrocarbon and 1 molecule of oxygen. So that's a rich mixture. And you can see this here. This is with your lambda and all that. You know, I created this chart for your enjoyment. And the same charts on this side, because a lean air fuel mixture will produce high NOx. The lean mixture is hot. You know, it's hot. It burns hot and slower, you know, which I used to think it burned faster, but you know, you can't watch this happen. But I mean, in one way or another, it burns hot. It burns slow. The hotter the fire burns, if it's over 2,500 degrees, I think that's 1,300 Celsius, the more NOx is created, and that's the nitrogen, which is a working gas. Basically, 78% of what goes in there is nitrogen, and it's inert. The oxygen is what unites with the hydrocarbons and makes the fire. 21% of that air is oxygen, 78% is nitrogen, 1% is trace elements. Okay, so when it gets over 2,500 degrees, oxygen and nitrogen will lock together in various different types of compounds. The reason this little X is there, because it could be any number, NO1, NO2, NO4, NO5, and that all has to be separated by that upstream cap. But the EGR, when you put inert gas in there, it doesn't burn because that inert gas basically makes the combustion chamber run just cool enough during the combustion event that it doesn't make as much NOx. And so, you know, of course, they're doing EGR on diesels now for that same reason. Well, that's the end of it. We've been here 26 minutes and 55 seconds. I hope you guys enjoyed this. Let me know what you think about it, and I'll see you next week.